In this example, we will find the volume of the solid generated by revolving the region bounded by x equals 0, y equals 0, y equals e to the x, and the line x equals natural log 6. About the line x equals natural log 6. Let's sketch the graph. The exponential function y equals e to the x equals 0, y equals 0, and the x equals natural log 6. This region rotated about the line x equals natural log 6. In this case, it's more convenient to use the shell technique. So make a partition parallel to the axis of revolution. We would get the solid of revolution for one shell that looks similar to this. To use the shell technique, we're going to need to find the radius of the shell. The radius of the shell measured from the axis of revolution to the partition or the bar that we formed. So this is the position x. The radius would be the right function, which is the x equals natural log 6 subtracted by the position x. The position x will go from 0 to natural log 6. So we have the interval of integration from 0 to natural log 6. And since we make a partition that perpendicular to the x-axis and parallel to the axis of revolution, so the thickness of the shell is delta x or dx. And the height of the shell is measured from the top of the bar to the bottom of the bar, which is from the curve y equals e to the x and the x-axis. So the height would be y equals e to the x. Now from the formula, the volume of revolution using the shell technique, which is b equals the integral from 0 to natural log 6 2 times pi times the radius, which is natural log 6 minus x times the height, which is the e to the x, times the thickness, which is dx. Simplify the term, so we get 2 pi integral from 0 to natural log 6 multiply the natural log 6 minus x and e to the x with respect to x. Now we see the product of the two functions. The first one is natural log 6 minus x. The second one is the exponential. Use the Lie technique to identify the two types of the function. So natural log 6 minus x is the algebraic. E to the x is the exponential. The algebraic is the u, and as we see, this is a polynomial function. Exponential e to the x dx is the dv. As u seen as a polynomial function, we're going to use the tabular technique or the tabular method. The left column, we find the derivative. The right column, we find the antiderivative. Starting with the left column, identify as a u or the natural log 6 minus x. The right column, starting with the dv, which is e to the x. Next, find the derivative of the log 6 minus x. Log 6 is the constant, the derivative going to be 0. The derivative of negative x is negative 1. And then another derivative to get 0. The right column, we find the antiderivative of e to the x to get e to the x, and then another antiderivative to get e to the x. Use the table to form the solution for the use of the tabular method. So the first product, we're gonna put the plus sign in the front. the second product, we're going to put minus sign in the front. Back to the problem. So the V as a 2 pi multiplied by, from the use of the tabular method, the first product is the product of natural log 6 minus x multiplied by e to the x with the plus sign for this product, and then minus sign for the next product, which is a product of -1 and e to the x. And then evaluate from 0 to natural log 6. If we expand it out, we have natural log 6 multiplied by e to the x minus x e to the x plus e to the x. Evaluate from 0 to natural log 6. Replace the value natural log 6 as the upper limit to get natural log 6 times e to the natural log 6 minus natural log 6 times e to the natural log 6 plus e to the natural log 6. Subtracted by, replace the x with a 0 or the lower limit, natural log 6 times e to the 0 minus 0 times e to the 0 and then plus e to the 0. 0 times anything, you get 0. Now we get natural log 6 e to the log 6 equals 6. E to the 0 is 1. 6 natural log 6 minus 6 natural log 6. 6 minus 1 equals 5. Therefore, the answer is 2 pi multiplied by 5 minus natural log 6 as the volume of this solid of revolution.